I'm finally finished with the Spectravideo SVI-728 project, and here is the result. The machine is finished. I'm really happy about that. I just came back from 4 weeks of vacation, and it's now in the beginning of August here. We had a really warm July and it continues now in August. Yesterday we had 30 degrees Celsius here, and that's not normal to say the least. So let's see this final part 3 of this project and see what I did. Alrighty, it's been a couple of weeks since I last worked on this machine, but in the between time I got some new parts for it. I got a new power supply, and I also got the correct cable for it. So no longer need to use this flimsy arrangement here. I also got a new VDP chip, and I also got this. This is a TMS-RGB module, and my plan is to use this for video output. And this needs to be soldered to the TMS chip, and it's going underneath the board, so it's going to be interesting to see if that will work. However, first of all, I need to get that composite video signal working, or the black and white signal working, as I did in the previous video. But first of all, I'm going to hook up the power supply and see if it actually works and has the correct voltage. This video is sponsored by PCBWay. In my videos I often have the need for some PCBs for my projects, and my favorite PCB manufacturer is of course PCBWay. If you need to have produced your own PCBs, then just head over to PCBWay, where you can upload your Gerber files directly, or you can choose from a wide variety of ready-made PCB designs. PCBWay can also support you in your other hobbyist needs, like 3D printing, CNC machining, sheet metal fabrication, injection molding, and other services. Also visit their shared project site, where you can find a lot of already made PCB designs. So go ahead and visit PCBWay.com and check out their services. That's minus and plus 12, 5 volts there and 5 volts there. Yeah. So now I can just desolder these wires and just cut one end of this and solder the contact directly, I mean the wires in like that. Alright, so that's soldered in correctly now. I think we have ground, we have plus 12, we have plus 5, and we have minus 12. Hopefully not gonna blow up anything. Always a chance. You see I cut off 2 of the wires that aren't needed. So now the board should be alive, and we should have 5 volts on some chips. Yes, 5 volts. So now I'm back where I were. We should now be able to see a black and white video signal on my TV if the board works as it should. But obviously there's no signal like before. However, I don't understand why I don't get the signal now like I did in the first video. So that's why I wonder if the TMS, the VDP chip, is gone or something else is wrong. The only difference between the first video and now is that then I actually just soldered the video signal to this connector here on the old video board, and I was thinking maybe there's some circuitry, or yeah, maybe there's some capacitors or something that made this work better. So I'll try that now. Look at that. Yeah, it actually works now. I hooked it up via the output connector on the old broken video board. So that's probably why it worked the first time too, because now there is something in that circuit. Well, then I'm relieved. The motherboard is working and the VDP chip is working. So I thought a little bit more about this, and it turns out it actually works just fine directly to the connector. So I think I just had a bad connection, a bad soldering or something. I switched to the white lead instead of this red, so I don't know. So if I now just hold it against the connector with my fingers, there you go. A nice, clear black and white signal. Now I'm one step closer to finishing this very long project. So the next thing I'm going to do now is to install this TMS-RGB. Might be a little bit interesting. See if I can pull off that. If you go to tms-rgb.com, there is an installation guide, and it's going to be soldered in like that under the board. A little bit of flux. Yes, I think that went well. Just gonna check that nothing is connected here. Yeah, nothing's connected and everything is solid. Then I'm ready to solder in the module. I'm just gonna clean it up a little bit first. It's going this way. Now it looks like this from this side, and next I'm gonna feed the audio, because I'm gonna connect the computer via SCART to my TV, and SCART also has audio, and the audio signal comes out from over here. So I just solder in a wire there. So now all of this is gonna be connected to this 9-pin DIN connector, and no, is it 9? 1, 2, 3, 4, 5, 6, 7, 8 pin. This is kind of a dilemma, because this is going to be assembled outside of the cabinet, and I need to make a hole for it. Then I need to wait to solder it in until I have done that, and then the motherboard will be permanently attached to the case, and I don't want that, so I need some kind of connector, I think. I have this kind of connector that you actually just clamp onto these flat cables. Just need to check that it's correct. This is 6. 1, 2, 3, 4, 5, 6. So it's gonna go from there. Yes. Now I regret I cut off this brown wire for the audio, because I need to fit that too. Okay, I'm gonna see if I can attach this connector there. Alright, so now that connector is in place, and checked all the connections, they're good. And this is gonna connect to the opposite connector like this. However, this is meant for soldering, so I just need to solder the wires into that. So I choose to solder in the other part of the connector on this little board, and the reason for that is it's going to be easier to solder the other side of the wires. And depending on what I need, I might need to install some resistors or even capacitors. But for the actual cable, I actually have this SCART connector, and it has all the 20 wires necessary. I already strip them and tin them up. Obviously won't need all of them, and this is the thing that's gonna be soldered to this, and that's gonna be painful. And even if this is an 8-pin connector, I only need 7 wires, so I have this 7-pin DIN on the other side. I couldn't find the 8-pin one. One problem with this SCART cable is that all the signals have their separate ground signal, and we only have one ground out of this, so that means I need to connect 4 or 5 different wires to the same ground pin on this, and or this, and that is perhaps not going to be easy. And also I just need to figure out which of these wires goes to which pin. And by some reason they decided to only use white and green, except for one red. Alright, so now it looks like this, and on the other side, yeah, this looks like a mess, but you know, the contact goes diagonally while the wires go horizontally, so yeah, every other goes to every other. Now before I do anything else, I'm gonna hook up the oscilloscope and simply check if we have a signal out of the TMS-RGB. So I'm just probing here. Yeah, for sure there's 5 volts. I already connected ground to the ground output lead. And yes, we have a signal. That's the red, green, blue. What about the sync? Yeah, so that seems to be working just fine. Now let me continue with the cable and finish it up. This is how the case looks, and yeah, I'm thinking just drilling a hole right here next to the TV out. Yeah, I have a bit of an issue here, you know, because if I place the power supply like this, it's too high for the keyboard, so I need to place it somewhat like this. Then it should work. Yeah. But then this connector comes awfully close to the power supply, so I put it all the way over here then. Then I drill a 16mm hole. I made some holes. Yeah, that fits. Have a couple of screws, they're a little long. And yeah, that should work. No, they're actually not too long. They're not longer than the contact itself. So now it's time to make the cable and connect this DIN connector here. And that's not going to be an easy task. Yeah, I have this table of the pins and where they go. So we don't need a lot of the pins on the SCART. We need 2 and 6, that's audio out. Then we have ground, and that needs to be connected to 4 pins. 17, 13, 9 and 18. We have the sync on pin 20. Pin 4 is blue, pin 5 is 11, pin 6 red is 15, and pin 7 is plus 5 volts. And then we have pin 1 down here. I marked it here, pin 1, 2, 3, 4, 5, 6 and so on up to 20. So I only need to then figure out which of these wires go where. That's going to take some time of doing continuity testing, but I'll be back when that's done. Alright, I have identified all the wires I need. There's 11 of them, and yeah, how am I gonna solder those to the DIN connector? Well, I thought, obviously since I make both ends, I could just use random pins, but I thought maybe if I make it compatible with some other machine, I might be able to actually buy a cable for this sometime later if I want to. So this is for the Amstrad CPC Plus, the 8-pin DIN to SCART pin mapping. And I absolutely hate soldering wires to DIN connectors. So what's pin 1 then? Well, it's actually labeled on here, and that's pin 1. I don't think it goes around like this. Well, pin 8 is in the middle, that's pin 6. That's how my connector is labeled. So this is the opposite end, which I'm gonna solder, and obviously it's this will go into the connector like this. So then it will be the opposite. So pin 1 on this is pin 1 here on the right side on this. Now a very important step, which I have forgotten many times before. Put the sleeving on before you solder. So this isn't by any chance easy, because it's quite fiddly and a stiff cable and a small connector. But I'm gonna solder together the 4 ground wires first. These 2 are for the audio. That's the 4 ground wires, and by using these helping hands I can just position the wire exactly where I want it, so that makes it a little bit easier. Yeah, that sits firmly. You need to be fast as well. You don't want to melt the plastic. Okay, I'm gonna solder in the rest of the wires and then I'll be back. Yeah, I think that went smooth. Looks alright. Hard to get in focus. The cable is finished. Hopefully it works. No, I'm just gonna double check all the signals from one end to the other. Now pin 16 on the SCART should have a 100 ohm resistor, that's plus 5 volts, and that's to trigger RGB mode. I didn't put it in here because it's a very small connector. I'm gonna put it in here instead. Alright, so I soldered in a 100 ohm resistor on pin 16, which, if I understand it correctly, is used to signal that the RGB mode is used. Finally, install this module and solder it to the contact here in the case. Just need to figure out which wires goes where. Okay, everything is soldered up. I didn't want to bore you with that soldering details. Now it looks kind of flimsy, but I don't know, the solder connections are good. I should perhaps have put some heat shrink sleeving over the whole contact there. I might do that later. But I think that's it. I'm ready to test now, see if we actually get some RGB out of this machine. Everything's hooked up. I connected the output connector to the inner connector. I connected the power supply connectors. I'm pretty excited now. I'm prepared for it not working. I did something wrong with the connections, but we'll see. Okay, turning on. No signal. Is it on SCART? Yes, it is. Okay, no signal. No, everything checks out. All the pins are hooked up correctly and there's continuity. Well, as you can see, I have come a little bit further and now I get some blue colored image. Sometimes it's like more of the screen, but yeah. The thing I did, I noticed that I didn't connect up the RGB, the blue ground, so I fixed that. I missed that pin completely. I think it's because I followed ChatGPT and didn't mention that that signal at all, so that's AI's fault. So I just desoldered the TMS-RGB module and resoldered it again because I was thinking maybe there were some bad solder joints. And then I got this first on my LCD TV, and then I just wanted to test with this CRT analog TV, and there's blue at least. We know that the screen is supposed to be blue. Well, 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 look at that. We have a color picture here. And what happened? Well, I just wanted to test if that black and white chroma signal still worked on my LCD TV. So I just hooked it up and holding it to the contact here now. And at the same time I had my CRT TV on and suddenly the picture appeared. Maybe there's some grounding issue or something. The picture looks alright, but yeah. It's a little bit noisy and yeah, I can understand that. But that means the cable is working. However, there's an issue. I don't know if it's some grounding issue or whatever, but I'll do a little bit more testing. As soon as I let go of that cable from chroma, dunk, no more picture. Yeah, I think I found a solution, you know, since that signal now is floating and yeah, you have ground. I thought, okay, maybe I need to terminate it with a resistor, and yeah, actually took a 1K resistor here, and now the signal comes right away. Don't ask me why, but yeah, putting a resistor there just fixes it. So I soldered in the resistor there between video ground and the Luma signal. So now we should get the picture on my modern TV. Let's check it out. So now maybe we get the picture on my modern TV. Let's turn it on. Yes, nice. Looks alright on this side. Over here it's more purple and more distorted. I don't know how to fix that. Does the keyboard work? Yes. Alright, so now I can test the MSX diagnostics cartridge, see if something else is wrong here. Oh, yeah. So what I'm gonna test? Well, there's a lot of graphic tests. Let's see, 5 system info. Yeah, 64K RAM, TMS-9929A, that we already know. How about audio? Yeah. Yes. I connected the joystick and yeah, let me just test this game cartridge. Yeah, and Athletic Land, well, the picture doesn't look too good, but I don't know. The audio is very good and loud, but now the colors were all washed out. Yeah, the colors, they don't look right at all. I guess this golf game is supposed to be green. It looked kind of nice in basic, but not now. Seems like blue is the only color that is a little bit powerful. Red, so that should be red. Well, that should be green and that should be blue. So that's black, but that's blue. So the colors are, yeah, completely wrong. Okay, I've been struggling for hours now. Yeah, I discussed with ChatGPT a lot, which I have starting to do lately, and that actually is helpful. But then I started to measure the voltages and the signal outs a little bit more thoroughly, and it actually turns out that one of the signals, the red, this is by the way a video chip, is connected to 5 volts. So here is the chip. It's a THS-7374 and it has 4 video channels out, but it has ground on pin 5 and plus 5 volts on pin 10. However, I also get plus 5 volts on pin 14. So pin 14 is shorted to 5 volts input. So I took out the TMS-RGB module completely and desoldered everything, and I grounded away the solder mask in this area. And if we try with the multimeter, so here's 5 volts input on this pin, and that is the 5 volt output. So they're connected, and we have ground there and ground on that pin. So that corresponds with the datasheet of the chip, but 5 volts is supposed to go there on pin 10, which it is, but it also appears on the top pin. And that means that the red signal is connected to 5 volts, and that destroys the color completely. I mean, I don't understand why it should have 5 volts to that pin. Then that means these 2 pins are also shorted together, which they are obviously not supposed to be. But I cannot see anything shorted. The 5 volts is the big area here, and yeah, that little trace there. I think this board has a fault from the beginning. It's nothing that I did. It might be the chip itself that has a short. Yeah, I cannot see that there's anything in the traces that touches. I try to cut in between up here, but it's the same. So heating up and try to rework this chip didn't help, but what I did next, I actually desoldered and lifted that upper pin, and it's now just sticking out into the air, and there is still a short to 5 volts. So I guess this chip is damaged then. I mean, there's not 5 volts anywhere else on this chip except pin 10, so it can only come from within the chip itself. Alright then, nothing more I can do here. I'm gonna order a new one of these, and then I'll be back. So I contacted the Video Game Perfection where I bought this, and Matt over at the Video Game Perfection, he promptly sent me a new one. No questions asked, so that's good. Good service. In the meantime, I'm gonna take a look at the keyboard. It's very dirty and yeah, missing some keys, as you know. So I'm gonna print the missing parts and yeah, clean the whole thing up. Strangely, there are two kind of keycaps. You see, one set has this shiny plastic on top, and one set has not. So I guess that's just because of language. All the numeric keys on top has that plastic on top. I've been looking for spare keycaps for this machine for a long time. However, I didn't find any. I could obviously buy a complete new machine or a complete keyboard. I think I found one complete keyboard, very expensive. What's the point in that? So I need 1, 2, 3, 4 plungers and 5 keycaps. To be able to replace the broken key plungers, I will need to open up this keyboard and remove the PCB. And it's quite dirty and dusty. Yes. Ooh, that's a rusty screw. Oh, it's very hard. So let's see how this works. No springs, but all these rubbery pads. Yeah, I'll take these plungers as well and clean them up. Well, that was a strange kind of keyboard. This rubber mat, yeah, it can be lifted. Nice. It's quite dirty. Alright, so the metal contacts, they look alright. Still, I'm gonna spray a little bit of IPA and just wipe over them. Alright, I'm gonna take everything for some cleaning and then I'll start printing some keys and then I'll be back. So everything went well with the printing and I cleaned up everything and now it's time to assemble the keys. After 3D printing, there's always a little bit of afterwork. You have this support material that fills up any, yeah, like cavities or something that is underneath the part. Because this is a little bit hollow downwards. And I did in fact try to print it one reversed, but then it will get better looking on the top. But still then I have to remove all the material on the other side, and I imagined it could be difficult to get all the leftover material out of this kind of cavity. It's easier on bigger parts. These smaller parts can be painful to remove the support material. Then we have the plungers, but they are a little bit easier. They have they're hollow inside as well. If you compare to the original, they're supposed to look like this. But it's not a problem if there's material deep inside it. I only need to remove from the bottom. I try not to break the side pieces here. Yeah, I think that's okay. Just clean it up a little bit with a knife. But they should fit, so yeah, they do. Yeah, seems to be okay. So where do these mats go then? Just gonna eyeball it. I guess they go right adjacent to the edge. Then we have all the keyboard plungers, and they're supposed to go just one direction. Not like that. So this is a lot of work. They need to fit down that track, yes. So how does the new 3D printed keyboard plunger work? Yeah, it's a little bit tight. So I think I need to file it off a little bit. These two works fine. Now comes the tricky part. I need to turn the whole keyboard plate around while holding this with all the key plungers in their down position. And I fear the mats will fall off. Yes. When I took them out, they had like some kind of glue. They were a little bit stuck down to the PCB, but not anymore. Or I need to try to position them onto the plastic instead. Maybe that's better. Yeah, seems like they're supposed to fit right on top of the edge. Yeah, there's some guiding plastic where screw holes are, so yeah, that's better, of course. I suppose this is working. The LEDs go right there. Yes. Yeah, there's also some plastic guiding pins so that you find the right position. By the way, there were some screws that had some rust, so before I do the rest, I'm gonna apply a little bit of 35% vinegar and let it work for maybe an hour, and that should remove the rust. It's acid, so it should dissolve a little bit of the metal and the rust with it. And after that I just use a little bit WD-40 on the screws after rinsing them off and drying them. Alright, I finished with the keyboard for now. It doesn't look great, but it is functional. The print, the writing on the keys, it doesn't stick. The pen I used is obviously poor, not good. I wrote this yesterday and still it's not stuck to the plastic. This one sticks a little bit too much up. I might want to cut off that plunger a little bit. Yeah, but otherwise it's functional and should work fine. Alright, so it's been a couple of weeks now and I got a new TMS-RGB module. Let's see if this one works better. There you have it. I also decided I'm gonna remove this stuff here. I don't see any need for it. My plan was to have it in case I needed to install some resistors or anything, but doesn't seem to be necessary. So let me just compare. As I told you before, there's a short between the 5 volt and the red on the old one. Let's see if it's the same here. No, it's not. Yes, I'm not gonna make this longer than necessary. I'm just gonna solder it in and remove this stuff here. I mean, the wire is long enough, and then I'll be back. Alright, the new module is in. I soldered the cables directly to it, and let's test. Well, it works, but yeah, the color is kind of off. It looks blue on the camera, but it's more like grayish. Well, the color test, this is white, this is black, they look good. But red, green and blue is nothing, no colors. Yes, I finally got it working. Yes, I'm so happy now. Cheers. Pepsi only. Yeah, let's take a look. White, black, red, green, blue, looping. I mean, the picture looks very nice, but maybe not on the video. Colors are always different on the video than for real life. I have no means to capture this, so I can only film the screen. Yeah, but what did I do? Well, let me show you. So I previously discovered that I needed to ground one of the original video outputs. In order to get a picture at all, I used this potmeter here, and then I got the picture. However, I was thinking, okay, maybe I need to ground all three of the video signal outputs, so I put in three 1K resistors there to ground, and that was it. So now it works. The other TMS-RGB module was definitely not working correctly. However, now it works, and this is how it looks now when I remove that stuff I had before. So now I'm simply gonna arrange everything and yeah, put this machine together. I'm very happy to be finished with it now. I really used a lot of time on this project just to get a decent video signal out of it. And keyboard works nicely. Yes, that has a lot of colors. Looks more normal. The red seems a little bit weak. It's more like pink. Maybe if I adjust some resistors or something, I can get it better, but for now I'm not gonna do that. Now I'm just gonna assemble the machine. So I'm debating with myself how to mount this power supply. I made this little plastic cover under it, but I don't know if it's necessary. It takes extra space, and there is one screw hole mount there, which I actually can utilize to fix this in place, and then it won't go anywhere. And then I use some glue around the edge here. For extra safety, I just add this double-sided padding on the other side. Then I screw it down. Yeah, I think that's good enough, in fact. No need for any more glue or anything. This won't go anywhere. I was thinking about adding a switch to the power and maybe use the original switch, but yeah, there's simply no room, and I don't think I need a switch. Maybe I find another switch or another solution to that problem later. Just a little final touch, and I think I'm ready to close this machine. I didn't bother to put in this back shield because I don't see any need for it now. Alright, final thing is to close up this machine. So that was it. I'm done with this project. The machine has been upgraded to RGB, and it has gotten the new keys. 3D printed, not as nice. I need to find another way to print the letters, but this will have to do for now. Now I'm just gonna run the final test here. So now this should just easily plug into the side here. Yes. Oops. Yay! I'll try this athletic land again. Yeah, now it's a lot more colorful than before. I still feel the colors are a little bit off, but I think this is much better than RF or even component. Yeah, let's play a little bit. Oh no! What the heck is this? Oh, joystick does nothing. Ah, now I get it. You need to hold in the trigger, and there's some balls going up here. Yeah. Okay. Alright then, that was it for this video. I'm just happy I'm finished with this project. I think I used almost 1 year in total on this machine. Not in time, but in time span. Anyway, I hope you enjoyed this video and that I'll see you back in the next one. Don't forget to subscribe. See you later. Bye bye.